Okay, objective 2, the second part of it, where we're still examining some radical equations, but these are a little bit more challenging. So the ones that we've looked at so far, there's only been one square root. What if there's more than one square root? Okay, that's what this is all about. So the title up there, you can see it says squaring ad nauseum. What that means is that you're squaring over and over and over again until it makes you sick. Ad nauseum, that's what it means. Okay, so what we're doing is we're assuming that we have more than one square root in your equation, more than one radical term. So step number 1 there, you're going to separate your radicals. One on one side of the equation, one on the other side of the equation. Okay, now to get rid of your square roots, you have to square both sides. Now, sometimes that might make both of the square roots disappear, but sometimes it won't. You're going to see that in the next lesson, the next slide. Sometimes you still have a square root in there. So, step 3, you have to isolate that new square root, isolate that new radical. And then how do you get rid of that radical? Well, now you're going to have to square both sides again. And then, hopefully that gets rid of the square root. You might have to keep doing that multiple times, whatever, until all the square roots are gone. And then finally, step number 4, solve and check that resulting equation once all the square roots are gone. Let's try that right here. So, you can see I have 2 square roots, and I'm supposed to separate them. Theirs are already separated. They're both on opposite sides of the equation. So I'm going to go ahead and square both sides. Square and square. Okay, I'm going to write over here so I have hopefully enough room. On the left hand side, that's the easy one, x plus 6 is equal to, now on the right hand side, this is where it gets a little tougher. So realize that this is really a binomial. It's like this, a minus b, that I'm squaring, where your a is the same thing as this square root that's right there, the square root of 11 minus x. And the b is the same thing as 3. Whenever you square that binomial, it's supposed to be a squared minus 2ab plus b squared. Okay, so that's what we're going to have to do on the right side of this equation. So my a being the square root of 11 minus x, when I square that, I'm just going to get rid of the square root, so it's 11 minus x. Okay, now I'm supposed to have minus 2 times a times b. So that's these two things multiplied together and then doubled. So minus 6 square root of 11 minus x. And then finally my b squared, so that's my 3 plus 9. So can you see, I just squared both sides and I didn't get rid of all the square roots. I still have one in there. Actually, I generated a new one. So I'm going to isolate it. That's the next step. Since it's negative, negative 6, I'm going to add it to the left-hand side so it stays positive. So 6 square root of 11 minus x. Get everything else on the other side of the equation. I got 11 plus 9 is 20. And then I'm going to subtract the 6 from the other side. That is 14. Then that x combines up with this negative x, negative 2x when I subtract it over. Hey, everything's even. Let's divide by 2, make it a little bit simpler. So I have 3 square root of 11 minus x is equal to 7 minus x. Okay, now I have a square root. How do I get rid of it? I square both sides. Now this is not, I know what you're thinking, this is not the cube root, that is 3 times the square root. Okay, don't let that confuse you. So square roots are square both sides. When you square both sides on the left, make sure the 3 gets squared. So it's 9 times 11 minus x when the square and the square root cancel out. It's equal to, and then square this binomial, 49 minus 14x plus x squared. Okay, on the left-hand side, distribute here, 99 minus 9x is equal to 49 minus 14x plus x squared. Alright, it's quadratic, get everything on one side. 0 is equal to, well, let's put it in order here, x squared, let's see, add the 9 over, so I'm going to have minus 5x, subtract the 99 from the 49, I'm going to have minus 50. So whenever I factor that, that should be also pretty easy. I got x minus 10 and x plus 5. Okay, so this means I could possibly have two answers here. X is equal to 10 and x is equal to negative 5. Let's try them both out. Okay, so on the 10, I'm going to plug the 10 in there back into the original equation. So I'd have the square root of 10 plus 6, which is the square root of 16, which is 4. Over there on the right hand side, let's see, is that equal to square root of 11 minus 10 minus 3 that's the square root of 1 minus 3, which is 1 minus 3 is negative 2. That does not work out, so that's not one of our answers. Let's try green. So negative 5. Square root of negative 5 plus 6 is the square root of 1, which is 1. Try the other one. Square root of 11 minus a negative 5 is going to make it plus 5 minus 3. Square root of 16 minus 3 is 4 minus 3, which is 1. Awesome. So that one does work. Whew, man, was that a lot of work, but rewarding. Man, payoff was pretty great on that. So you'll probably want to try this one on your own. Alright, so it turns out that I don't think that one was quite as tough as the last one, was it? Because you didn't get a quadratic when you were done. So whenever you squared both sides there, the left-hand side, that's the one that turns into the binomial, and you still get a square root. You get negative 4 times the square root of x plus 6. So I want to add that to the other side so it's positive, get everything to the other side, and that's where the x is canceled. And hey, that's kind of nice, because then you're left with a linear equation at the end. I get x equals 3. And then check it just to make sure nothing's extraneous. And it worked. That's good. Okay. So we're looking at equations that had square roots in it. And we talked about how fractional or rational exponents, same things as radicals or nth roots. So why don't we just go ahead and throw those into equations too? Okay, so if you look right there in the center of the screen, x minus 4, all of that raised to the 2/3 power minus 9 is equal to 16. If I wanted to solve that for x, you want to get that radical term, that's the one with the fractional exponent, all by itself. So you have to add the 9 over. And then you raise both sides to the reciprocal power. And that's because that's going to be the inverse. It's going to be the inverse because if you multiply a fraction times its reciprocal, it becomes 1. And when your exponent's 1, then you have no square roots anymore. And then finally, solve and check. So let's try that right on that one. Same exact equation. So isolate the radical term, so get the 9 over. So I have x minus 4 to the 2/3 power is equal to 25. So I'm going to raise that to the reciprocal power. So I'm going to raise both sides of this to the 3/2 power. So 2/3 times 3/2, whenever I raise a power to a power, cancels out and gives me 1. So that's why I do this. That's why the trick works. And I'm just left with x minus 4. And then on the left-hand side, that's the same thing. So square root, because it's 1/2, so it's the square root of 25, all of that cubed. Square root of 25 is 5, and then I'm cubing that, which is 125. Okay, and then finally add the 4 over, so I'd have x is equal to 129. Okay, let's check it, put it back in. So I'd have 129 minus 4 raised to the 2/3 power minus 9. So inside the parentheses, I'd have 125 to the 2/3 minus 9. So take the cube root. The cube root of 125 is 5. 5 squared is 25. 25 minus 9 is 16. Check! it wasn't extraneous. So, why don't you give that one a try, right? Something new, something fresh, you want to try it to make sure that you understand what's going on. All right, so were you able to pull it off? Is this what you got? X equals 6. Whenever you isolate that radical there, raise it to the reciprocal power, so 3/2, and it gets rid of all of the radicals, and you get 6. Plug it back in, check it, it works, and you're good to go. Okay, I'm going to show you one last example, and this is where things get kind of crazy here. So take a look at that equation right there in the middle. Might be a bit intimidating, but it's not if you do some sort of clever substitution. So what you do is you take the middle radical term, which in this case is this part, ignore the 3 because that's just the coefficient, and you set that equal to your favorite variable, like k. And then you turn that equation into something simpler to solve. So that turns into k squared plus 3k plus 2, right? This is the same exact equation as this one in the middle, as long as you understand that k is supposed to be equal to 3x plus 1, all raised to the 1/3 power. Okay? And then we'll unsubstitute that at the end. Let's see. So, like I said on the previous slide, k is going to be equal to 3x plus 1, all of this raised to the 1/3 power. So you always take whatever is the middle term there. So that makes our equation into k squared plus 3k plus 2. And now it's quadratic, you just factor that thing. So this is going to be a k and a k, and a plus 1 and a plus 2 equals 0. Okay, so then I need to set each one of those things equal to 0. So I'd have k is equal to -1, and I would have k is equal to -2. On the -1, over there on the left-hand side, it's not really k, it's supposed to be 3x plus 1 to the 1/3 power. So I'm going to put that back in. 3x plus 1 to the 1/3 power should be equal to -1. Now I have just a regular radical equation. I get rid of that radical by raising both sides to the 3rd power, 3/1, to cancel it out. And I would have 3x plus 1 is equal to -1 to the 3rd power stays -1. Subtract the 1 over. 3x is equal to -2, so x is equal to -2/3. Okay, let's look it over here on the other one. Do the same thing. Get rid of the k and put back in what you substituted, which is 3x plus 1. That's a 1, not a parenthesis. 1/3 power is equal to -2. Cube both sides to get rid of it, so 3x plus 1 is equal to -8. Subtract the 1 over. 3x equals -9, so x is equal to -3. See? See how simple it became whenever you looked at it from another perspective. Now, we'll also do something like this again whenever we solve some exponential equations in the next unit. So there's something to look forward to. That concludes our lesson on rational exponents and nth roots, together with solving some radical equations. And we know that nth roots and rational exponents mean the same thing. And whenever we have radical equations, we are basically separating the radicals, squaring both sides or cubing both sides to get rid of it, and then you solve the equation that you get as a result. Okay, so here's your assignment. And there's Rowan trying to start a new expression. That was squarely radical. It's pretty funny. Not really.